Ever wonder how complex software systems deftly manage who gets to do what? How do these intricate platforms ensure the right people have the precise access they need, all without spiraling into chaos and security vulnerabilities? Absolutely, there are indeed distinct design patterns for role-based access control, or RBAC. These patterns offer various levels of granularity and complexity, specifically designed to meet the highly varied access control needs of modern applications. At its core, RBAC is a powerful abstraction where permissions are assigned to roles, and then users are assigned to those roles. This fundamental concept simplifies access management immensely. However, real-world systems are rarely simple, leading to the evolution of several sophisticated RBAC design patterns. One common pattern is hierarchical RBAC. This model allows roles to inherit permissions from other roles, creating a clear chain of authority. Think of a senior manager who automatically gains all the permissions of a regular manager, plus additional administrative privileges. This approach greatly simplifies permission management for related roles, making it easier to maintain consistency. Another crucial pattern is constrained RBAC. This design builds upon the basic model by incorporating additional rules and conditions into the access decisions. For instance, it can enforce the principle of separation of duties, ensuring that no single person can perform two conflicting tasks, such as creating an invoice and then approving its payment. This pattern significantly enhances security by actively preventing potential fraud and insider threats. Then we encounter parameterized RBAC, which takes granularity to an even finer level. In this pattern, roles can include specific parameters. So instead of just a generic manager role, you might define a manager of Project X or manager of Department Y. This allows access to be highly context-specific, offering very fine-tuned and dynamic control over resources. It is also incredibly useful to understand the relationship between RBAC and attribute-based access control, or a BAC. While RBAC primarily focuses on what a user is, referring to their role, a BAC considers who a user is by evaluating what attributes they possess. These attributes could include their location, the current time of day, or their specific security clearance level. Often, a BAC complements RBAC, providing an additional layer of dynamic and context-dependent access decisions, particularly in highly complex or evolving environments. Choosing the right RBAC pattern for your system involves carefully evaluating your application's specific security requirements and anticipating its future growth. You need to consider the level of detail required for your access decisions. Do you need simple, broad role assignments, or do you requiring intricate rules and deep context awareness? A wise approach is to start with the simplest pattern that effectively meets your current needs and be prepared to evolve and adapt as your application's complexity and security landscape expand. Implementing these advanced RBAC patterns allows you to rigorously apply the fundamental principle of least privilege. This critical security tenet ensures that users are granted only the absolute minimum access necessary to perform their legitimate tasks, thereby significantly reducing potential attack surfaces and minimizing the impact of any compromised accounts. It establishes a robust security posture while efficiently managing administrative overhead. By thoroughly understanding and strategically applying these diverse RBAC design patterns, developers can architect highly secure, resilient, and manageable back-end systems. This proactive approach ensures that your application remains protected against evolving threats, scaling effectively with both your organizational structure and your crucial security needs.
If this helps you code smarter, like, subscribe, and stay tuned for more.